Hello. This is a makeup session that I want to record it for you so that we can be on the same page before the midterm. The midterm is coming up next Wednesday, so I think by all means I want all of you to get prepared. And I'm really sorry that I couldn't make it to Wednesday's class because of sickness. So that's why I'm recording this video so that I still have a chance that we can all finish the last little bit. So last time, what I remember is we've been talking about the forward or futures price, right? So we haven't talked about the forward futures value. So the price, so I have to write it with my hands. These pens don't work that well. The price is equal to, what is it? S0 exponential RT. And then we talk about why the price is true. It's true because if it's not true, then there will be arbitrage. Namely, these are the no arbitrage prices. Now, on the other hand, if we have some kind of variation, so we were kind of in the middle of the variation part and say, suppose the underlying asset is going to have some kind of generate some kind of income, and we denote I as the present value of all incomes. Then what should you do? Well, you should really subtract, subtract the income, the present value of all income from the underlying spot price, or the F, usually we denote it as F, the futures of forward price, exponential RT. Okay, so that is when these income are discrete. And we argue that why should I subtract the I from the S0? Because S0 as the sum of present value of all future cash flows, not futures cash flow, future cash flows. Future is here is in the usual English sense. So if that is the case, there are part of these cash flows that are not received because you are now holding the futures contract in place of the actual asset. So namely, if you're going to hold the actual asset, that asset is going to bring you all these present value of income. However, since you are not holding the asset, you're now holding the contract instead. The contract is when the contract is lasting in the duration before the contract deliver or expires, there will be this amount of income that will not be received by you, because remember, you're not holding that asset, you're only holding the right to buy that asset. So, or obligation, right, and obligation in this case. So in this case, you are going to have to subtract this I from the S0 because it's a part of the value that you are not receiving. So the fair price will be taking S0 minus I. Okay, so as the board is getting a little bit messy, let me create a new board and try to talk about the second one, the second variation. Let me change the color. What is it? Well, how do I change the color? Oh, yeah. Okay, so what about the variation number 2? With income that is received or generated continuously. What kind of security actually generate a continuous income? Well, actually none of them, except for if you have a portfolio of security. So now here we're not talking about individual securities. We're talking about a portfolio of securities. And so, for example, a famous example are the stock indexes, such as, say, SP 500. If you're looking at an index like a SP 500, all these indices are portfolios of stocks or portfolios of securities. So if you have a pool of securities, then you're going to have the whole pool of securities having dividend here and there. Okay, so if you look at the whole pool, then it will be, say, one dividend today, two dividends next week, another one, and then a couple of the week after, things like that. So it will be tedious and not informational if you count individual dividend that people so get so bored of it, and that's why people start to count the dividend, kind of smooth out instead of having like one dividend, two dividends, and a bunch of dividends, and this. And because dividends are constantly coming you now because you now have a pool of securities that are going to get dividends coming at different time points. So you're going to smooth it out and kind of take an average and say, hey, what is the equivalent continuous dividend rate or dividend yield that we call it? Dividend yield. What is the continuous dividend yield? So this dividend yield, remember, yield or return kind of on the percentage sense, right? So these are going to be like a rate sense. Okay, so anything that is a continuous, if you see the wording of continuous, the dividend yield, then it's not going to be dividend in dollars. It's not going to be $3, $4. It will be certain percent. Make sense? So once we smooth it out, then we can say, oh, for this index, the annual dividend yield is so and so percent. In fact, it's not receiving a continuous one. The continuous one is the equivalent one, equivalent to over the whole year. What is that constant and the frequent process of receiving many dividends? Okay, so that being aside, how is that going to affect our way of calculating things? So let's come back to look at this formula. Well, if we are going to remember when we add in the discrete one, I, we kind of group it or marry it to the spot price, right? So what if we are going to add in now a continuous dividend yield? We call it Q, dividend yield, continuous. So if that's the case, which one should we marry it to? It looks like it would be better off getting married with this one upstairs, right? So this is an upper class marriage now. So we're gonna have this F as 0 exponential. Hey, are we going to add it or subtract it? Well, you're gonna remember you're always going to add the cost back or subtract any income, because these are the things that you're not receiving. If you have a cost, you're not paying the cost. If you have an income, you're not getting the income, right? So you kind of have to reverse the process, if you will. So we get this R minus Q times T. Okay, So fair enough. Now we understand that what if we have a continuous dividend? Suppose we say that, now I'm pulling out there for the convenience. Suppose we have an example and say, we say that today's stock index is, I don't know, 1,023. Okay, I confess, I was not looking at the market today. So I'm just saying an index that is 1023.93 today. Okay, if you're going to have a futures contract on it for the following 6 months, or equivalent to half of a year, then what if the interest rate right now is about 4%, and the dividend yield of that is 1.2%, then what do? What do you have? Well, you're going to have the futures price equal to 1023 times 90, not 90, times 93, and 1.23.93 exponential of what? 0.04 minus 0.012 times 0.5. Okay, so if you calculate that one out, let me try to do that one properly using my cell phone. And please use this time to calculate it by yourself as well, and let's try to get the same number. Minus 0.012 equal times 0.5, yeah, and exponential times 1023.93. So that is going to be equal to 1038.36. Okay, you get that? It's fairly simple, right? So let's look at one of the questions in the review test. Okay, so share the application, just an application. I want to share the Word file. Right, so, okay, we are going to look at question number 6. Okay, so it says that the current price of the gold is 300 per ounce. The gold storage cost is a continuous cost of 3%. Okay, oh, now even storage cost has a continuous rate, right? So if the interest rate is 4%, what is the futures price for futures of gold delivering in 9 months? Okay, so what is T here? What is T here? Let's figure out it one by one. T is equal to 9 months divided by 12 months. That should give you what? 0.75 number of years. The current gold price is equal to what? 300. Okay. Storage cost we call it lowercase u. It's a continuous one. Okay, it's going to be 3%. And the interest rate is going to be 4%. Now, we just talked about the continuous income. What about the continuous cost? Well, remember, subtract any income, add back any cost. So what you're going to do is you're going to have the futures is going to be equal to the current stock price multiplied by the exponential of the interest rate plus the storage cost U times the T. Okay, so it was the RT itself, but now it is R plus U times T. Make sense? So this is what you're going to do. And you're going to see this exact formula in the formula sheet as well. So let's do 300 times exponential 0.07, right? Because it's 0.03 plus 0.04. So times that to 0.75, and that should give you how much? I should give you 0.07 times 0.75 exponential times 300. It's going to give you 316.17. Okay, so similar story if you have the storage cost capital U. So suppose if you have storage cost capital U, then that capital U is going to be added back to x0. R and T. Okay, so just be very careful on what you are going to, which one are you going to narrate it to, right? So remember the capital one, the discrete one, the present value of all the discrete income or storage costs are going to be married to the current spot price, the one downstairs. What about the continuous one? The continuous one is going to be married to the interest rate, the one upstairs. Okay, makes sense? So that is going to conclude our all variation of the variation of the forward price and futures price. Okay. So okay, coming back, let's talk about the value. So we talked about the price so far. The price. What is the price of futures? It's not going to be it's not equal to value in this case, even if market is efficient. Why? This price is the price for your future trade, the trade that you delayed. Remember, that was your trading price for the spot asset. It's actually not the value of the contract. So at the very beginning of the contract, there's no value. So at the initiation, value is equal to 0. Why is that? Well, because suppose you think about A and B, these two agents, they are trading with each other. If that contract is having $10 value, I'm sorry. Hello?